Zombieverter. Hello folks, and welcome to what is unfortunately going to be, quite probably, a long and boring episode. What we're going to be dealing with today is the Zombieverter VCU, and primarily the new version 2 firmware for said Zombieverter VCU. Now, first of all, I know it's been a few weeks since my last video, and apologies for that. It's just been kind of crazy. Once I got into the software, it just kind of grew like a bit of a mountain, and I had to keep on climbing. So, just to, I suppose, fill in a little bit of the backstory. Johannes has done a lot of work on the software for me when he was away on his winter holiday. And I didn't really have a chance here to do any testing on it. So like a lot of things, I guess there was other priorities going on. So I eventually figured that I had better set up some test bench here, more than the very basic thing that I had, and start working out some of the kinks. So basically that's what I've been doing for the last 2 weeks here. What would happen is I'd solve something, I'd have it working, and then I'd realize, but now I can't do this with this and that with that. So then I had to kind of backtrack and go in there and basically change quite a lot of the structure of how the various modules within the VCU software are actually handled. So the big changes, I guess the headline changes that you're going to see in version 2 are that all charger modules, so all AC onboard chargers, can now be used independently of inverters, vehicles, and charging interfaces, including fast charging interfaces like the LIM and the built-in Chademo system. And I've also got another charge interface that Tom designed that I have to integrate. But all of these things are now a lot easier because of the kind of virtual function system that Johannes implemented, and I just basically then copied that into a lot more of the systems that the VCU can control. So that's all well and fine. We can churn out code all day, but the most important thing then to do is to have facility here to kind of test and debug the various systems. As it stands now, at the time of making this video, I have 2 cars that can be used, but I don't like just throwing software into the cars straight away before we kind of find obvious problems here on the bench. So my bench at the minute, I'm working on a third setup here that you'll see hopefully soon, but I've got 2 setups. The first uses all current limited power supplies and is perfectly safe to test any kind of crazy software. This is my first kind of port of call here. It uses the GS300H gearbox and inverter. And my next setup then that we'll show you is a complete 110 kilowatt Gen 3, I think it is the Gen 3 Nissan Leaf stack, and also One new feature that hasn't been there before, it'll be in V2, is the CAN control of the BMW S box, safety box, contactor box, whatever you want to call it. So not only now can we read the current and the voltage, we can control the relays, the pre-charge and all that via CAN. And that's now an option in version 2, so you don't have to use the ISA shunt. And Jamie Jones has done a ton of work on the Volkswagen, I think it's the Golf GTE version. So we're going to have that implemented in the VCU as well. Not on version 2, but very soon after, because I've literally just spent, I would say, 30 to 40% of the last 2 weeks actually writing code, and the bulk of it actually testing. And that testing has been here on the bench, in the cars here just around the property, in the cars out on the road, and then in the cars bringing them to the fast charging station, nearest of which is about a 30-mile round trip from me. So things that are combinations now that are working. Try and pull this off the top of my head. Obviously we've got GS300H on the bench. We've got Leaf Gen 3 stack here. You can use it complete. You can use the PDM. You can use the inverter, any combination. BMW S box, ISA shunt obviously works. GS450H in the E39 vehicle. Tesla Model 3 PCS controller. In the E46 then we have the Leaf Gen 1 motor and inverter. Model 3 PCS controller in there as well. Vauxhall Ampera heater. There's quite a lot going on there. Obviously then fast charging in the E39 we have the Chademo, the built-in Chademo in the VCU, and in the E46 with our CCS and AC via the BMW i3 Lim. There's a lot of threes in this stuff. It's not just this Model 3 thing here. So yeah, lot of testing. I didn't really bother filming much of that because it, as fun as my videos are, they would have been even more fun had I been filming about, I don't know, let's call it a week of solid testing. So what I hope is that this version 2 brings along some nice features, tidies up the use of the various modules in there. And also Johannes brought in some other vehicle module. There's now a mid-90s Subaru in there. And he also brought in this I/O matrix, so you can now choose from a menu on the web interface what the various I/O pins do. So it kind of decouples it from the from my kind of hard-coded functions for the various pins. So all that's really good. Big thanks to Johannes for the effort that he put into doing that. Now that I'm up and running here with testing, hopefully fairly soon, i.e. within the next couple of months, we're going to be able to bring in BMS support very soon, and also the much sought after regen, because now I can test it across the various bench setups first, and then in vehicles here before even thinking about releasing it for you folks. But that is coming, because now we've got our facilities set up again. So I'm going to cut you in for some of the bits that I have filmed, and also in there then you will see a exceedingly boring run through of the web interface, so enjoy. As it turns out, I'm a complete idiot. So one of the things here that's been kind of staring at me for some time has been my Volkswagen chargers. So for some of you that may have been around here before, oh, I can turn off the battery here. I was doing some PDM tests. So, you may remember I got the Volkswagen PHEV 3.3 kilowatt charger to work, but I had absolutely no success with the larger 7.2 kilowatt from the Seat Me and the 11 kilowatt beast down here from the Audi e-tron. Now, going to put a link in the video description here. There's a very smart man that has basically not only managed to get the e-tron charger working on the bench, but is able to reprogram it so that we don't need any of this nonsense here, like this LIN controlled door and all of this can go away. So I'll put a link in the description to his video, and I'm going to have to obviously try to follow along there, but I've got to figure out VCDS and VAGCOM cables and coding and all of this. So I'm already pretty good at that on the BMW stuff, but I've never done it on the VW stuff. So yeah, I'm gonna be on a bit of a learning curve on this one myself. Probably make quite a few mistakes on it, but definitely coming along to a VCU near you will be the control of not just the PHEV charger, but will be the larger 7.2 and 11 kilowatt variants also. Okay, this is going to be some serious Blair Witch shaky phone stuff, but okay. The Robins are now in here. So if you see, we've got the yellow, the red, and then the yellow drawer on the right hand side. The Robins are in there. Can I zoom? Oh, we can zoom. Oh yeah. This is going to get really shaky now. So the Robins are in there. Can I get us in a bit? Oh. Okay, let's zoom back out a bit. Let's see if we can get in and say hello to them. Obviously don't want to scare them. I'm pretty sure Mrs. is in there. Oh yeah, there she is. I see her. Now, let's see if I can wedge the phone on the Panzer's bonnet. Okay, folks, so what we're going to do in this section is we're going to have a look at the web interface. We're currently connected up to my kind of what I call my bench test part 1 here, which is our little safe setup. So we'll show you what I'm going to do really is I'm going to just focus on the things that have changed on the web interface between earlier versions and version 2. Most things are the same. So I'm going to skim over the stuff that's the same. If you want to see info on that, I'd suggest watching some of the earlier videos. But so without further ado, let's go have a look. So the web interface is the same, obviously, as the one that's used on Openinverter. So a couple things just to point out straight away here. Of these buttons here, save parameters to flash, restore parameters from flash, display error memory, reset CAN mapping, and send custom command work as they should. The buttons start inverter in manual mode and stop inverter have no effect. So just to keep that in mind. I'm not going to go through, as I say, the basics of updating software and all that. That's been covered in the past. Parameters, likewise. So all of this stuff works as per Openinverter. So let's take a look in our general area here, because this has changed a little bit. The first thing, the first choice that we have to make is what inverter that we're going to use. So at the minute here for our bench number 1, we have our GS300H. You can see here, if you pull down that menu, the various choices that are currently implemented. It's worth noting that whereas this one here says Leaf Gen 1, this indeed does cover all of the Leaf inverters, but what needs to be implemented and will be coming up soon will be a Gen 2 and a Gen 3 class that will allow the greater torque requests that those inverters can provide. Vehicle is our next choice. We pull that down, we can see the choices here. This remains the same with the exception of, thanks to Johannes, we can now choose Subaru. And that lets us, I believe, work with mid-90s, maybe late 90s Subarus. I don't yet have any instrument clusters or bits and pieces to test that with, so as of my testing here, that remains untested. Vehicles that I have tested in here are E46, E39, and Volkswagen. I have a test rig here for some of, at least, for our test setup here. Transmission lets us choose manual or automatic, simply because some of the vehicles require slightly different CAN messages depending on whether there's an automatic or a manual gearbox fitted. I'm thinking in this case particularly the E39 is the reason that I implemented that. So we then have a choice here, a menu system that lets us choose which of the two internal to the STM32 CAN buses, excuse me, that we can have for inverter, vehicle, shunt, limb, and charger. Under the throttle system here, things remain largely the same. The regen parameters are set to 0 at the minute because in version 2 we will not have as yet the regen system initiated. But as I mentioned, now that I have the ability to test this across a variety of things on the bench here, we will be soon able to start testing regen. So once I do, we'll have another segment here explaining how the regen parameters work. Rev limiter, voltage limits, voltage max, temperatures, all of this remains the same, trot min, trot max, all that. Trot dead is a new parameter and lets us specify how much of the initial travel of the throttle pedal in a percentage doesn't do anything. So I just have it set to 5% here. So the first 5% of the throttle that you press just doesn't do anything. Gearbox controls for our Lexus GS450H. couple of things are worth noting here. You can indeed select the high or the low gear in the Lexus GS 450h, and I'll show you that in the vehicle. The E39 has the GS 450h. But what you cannot do is use the automatic mode, or indeed shift them while the vehicle is moving. That is going to require some more investigation. Ideally, that somebody does and then contributes back into the project so that we can all benefit from it. Oil pump is your percentage of speed. What I found was, when I did the bench testing here, that anything above about 25% speed seems to satisfy the minimum pressure switch. So I usually leave it at 30%, which is a nice quiet setting, and also doesn't create that much noise, and it seems to be easily able to control the clutches and valves and all that kind of thing. So UDCSW, contactor control, that's all the same. So we have CAN 3 speed. So CAN 3, just very quickly, is a third CAN channel on the VCU that is dedicated to specialist tasks like Chademo, single wire CAN for example, the Ampere heater. It can also do fault tolerant CAN and a few other specialized CAN based procedures. It's not, as of the time of version 2, accessible as a general purpose CAN bus within the VCU. Nor would I necessarily expect it to be, because it's controlled via SPI, so it wouldn't have the same speeds and data throughputs as the internal CAN peripherals in the STM32. So this just lets us set the speed. There's two speeds available. 33.3 is typically used for the Ampere heater, and 500 for Chademo. So charge modes and the charger control section. While the actual menu, I guess the boards, whilst the menu doesn't seem to have changed much, there are changes within how the charger modules have been implemented within the version 2 code that allows much more flexibility. So let's have a look at charger modes. Now, charger modes is kind of a little bit, probably a little bit of a bad name. And what it's really doing is it's asking us to select what onboard charger, so AC standard charger, that we would have within the vehicle. So choices are off, so we don't actually have one. External digital. External digital lets an external charger request high voltage from the VCU by asserting a 12 volt input, and the VCU will then switch that charger on or off by the means of a 12 volt switched output that we can choose in the I/O matrix, which we will see later on. Volt ampere at the moment is not implemented. Leaf PDM. So what this does is it lets us use the Nissan PDM, or power delivery module, maybe, from the Leaf's DAC, either with a Leaf motor and an inverter or without. Tesla OI lets us control open inverter boards for Tesla chargers. So for example, the Gen 2 and the Gen 3 from the Model S, or the PCS from the Model 3 via CAN, selectable from the charger CAN, so we can use some of these parameters here to send voltage, current, power, and so on requests to our open inverter based charger boards. Now that module I need to fully test. It's not fully tested at the moment because I have only one vehicle that has one of those type of charger boards in it. But when we get the Panzer set up, we'll be able to do a full test on that, because as you may recall, the Panzer has the Model S Gen 2 charger. Battery capacity is just used for calculating SOC when we have the ISA shunt in there. So charger interface. What is the charger interface? Well, in this case, we have 3 choices again. We have unused, which means that we don't have any specific module connected to the charger port. So for example, if we had a Volkswagen hybrid charger, that looks after the charging port for itself, so we would have unused in there. We can then have I3 limb, which is where we have the limb manage our charging port, both for CCS DC and for AC standard charging. And we can have Chademo, which is the internal Chademo on CAN 3 within the VCU. It's worth noting that unlike in previous revisions of the software, you can have any combination of charge modes and charge interfaces now. So for example, you could have the Leaf PDM and a i3 limb. You could have a Tesla open inverter charger and Chademo. You can have any combination of these. Won't go through too many more of these guys here. These are all explained in previous videos. Heater module, timer. At the moment, the timer for charging works. The timer for preheating does not. I haven't implemented that in the code yet. Now, this is entirely, there's, make sure we can see all this, yeah. So, we've got an entirely new area here called General Purpose I/O, and we have a little bit of a change in the ISA shunt control. So we can thank Johannes for this new area here in the General Purpose I/O. And what this allows us to do is to take any of the outputs from the VCU. So the 3 low side, or apologies, there are 3 low side general purpose outputs here, and we can have a menu pull down to let us choose any of these functions for that particular output. There are 2 additional low side outputs that were traditionally reserved for use with GS450H gear shifting, but for example, if you're not using GS450H and or you are, but you're not bothered with the whole gear shifting thing, then these 2 pins become available as low side switched outputs, and you can choose from the menu system here as to what you would like them to do. We have 3 PWM outputs on our VCU also that feed into it's actually a low side MOSFET driver, so they can do 12 volt PWM signals. I believe Johannes has actually implemented the PWM timers on those pins for the Subaru vehicle class. But in the meantime, should you wish to, they are also available as general purpose 12 volt and ground switched outputs should you wish to use them. Keeping in mind that they are not overload protected like the out and SL pins, but there is a little fuse on there, so if you try to draw too much 12 volt power from them, you will pop the little fuse on the PCB. So this is our general purpose I/O. By default, when you load up the code, they are configured as I had originally intended them during the earlier versions of the code. So for example, output 1, coolant pump, output 2, negative contactor, and I believe output 3 and PWM 3 are turned off, but I've been experimenting here and running various tests. Now, ISA shunt control has a new menu choice, that is type. We have 3 choices in here. It's getting crazy. In here we have ISA, which is our standard our standard ISA shunt that we all know and love. We have 2 more choices. We have the BMW S-Box, which you will have seen here working on the test bench 1 and indeed test bench 2. We test the ISA function in our two cars. And we have the Volkswagen one, which as of version 2 is not yet implemented. So we now have a choice, as of version 2, to use an ISA shunt or a BMW S-Box. So for this bench here, we have the S-Box hooked up. So I'm going to come down to spot values here, and we'll just show you, as of, again, this version and this video, what we have functioning and indeed don't have functioning here. So the first thing that you will see, and I'm supplying my little bench rig here with 18 volts from a benchtop power supply. You'll see UDC2 here reading 18 volts, and UDC, which is the inverter side of our contactor, is pretty much reading 0. So in the case of the BMW S-Box, what's different from the ISA shunt is that we read under UDC2 the before contactor voltage. So this will be what would be if you were to connect up, as we'll show in a minute, to an actual BMW hybrid battery. This would be the reading of the full battery pack voltage, and UDC is the reading. Really, birds? Whoa, 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 whoa! Cool down, guys. Wasn't there an Alfred Hitchcock movie called The Birds? Okay, this video could end badly for me. Right, UDC is the after contactor voltage. Really? Well, I have a pair of white noise generators have entered the barn, so that's useful. Thank you. Now, so UDC 3 is not used, and at the moment I haven't found I think I have found it, but I haven't implemented the power, kilowatts, kilowatt hours, or amp hours, but we have indeed got DC current, before contactor voltage and after contactor voltage, and we can of course control all three of the contactors in the BMW S-Box via CAN. So if we were to go back up to our setup here, shunt CAN then lets us choose which of the two internal CAN buses that we would either have our ISA shunt or BMW S-Box, and hopefully very soon the Volkswagen version of that. I do, as I say, thanks to Jamie Jones' work, have the Golf one that I can switch the contactors in it, but I haven't figured out the Passat one as yet. So, just to show you this working, what I'm going to do is I'm going to put the web interface on auto refresh, and I will go ahead, oh yeah, it's working away. I'll go ahead and switch my ignition on and just tap to start. And of course, decides not to work because I'm filming. Yay, there we are. Okay. So, we can now see that we have 18 volts on UDC, which is the inverter side. And if we look at inverter UDC here, that matches. And we'll see here that as the Lexus and Toyota inverters do, they draw a little bit of current here just when they're idling. So the BMW S-Box works. Actually, I think the way that I tend to work is that negative current is current coming out of the battery, positive current is current coming in. So if I grab my throttle here, put a little refresh, yeah, you'll see that we're drawing a little bit more current there with some RPM and so forth. Now, there's a few things about the operation of the VCU that I'm going to demonstrate now because it'll be easier to see them here on the web interface. Okay, so right, let's switch off our ignition. So there were a few little, and I won't say little because I discovered one of them, or it was discovered for me recently, much to my displeasure, mechanisms within the startup and shutdown control, which is called the mode control section, that would, to use a euphemism, result in an undesirable outcome. So what is an undesirable outcome? Well, for me, in the E39, that resulted in a blown pre-charge circuit. So it destroyed the pre-charge resistor and the pre-charge relay and left me stranded about 20 miles from home on a Sunday in a small Irish town where the only shop open was what we used to call a pound shop here before the euro came in. So I had to do a bit of a MacGyver involving a set of steak knives, duct tape, some kitchen kind of clamp things I guess you'd have for, I don't know, clamping posters or stuff. What else did I get? Oh yeah, unfortunately some old school filament spotlight bulbs. So that'll be for a future episode. But anecdotes aside, that led me to obviously looking into how that actually could occur. I was able to easily replicate it here on my test bench. And that was one of the catalysts that happened about 2 weeks ago that brought me back into the whole VCU firmware. So we can thank a certain person for causing me that little bit of grief, but I think the ultimate outcome of it will be very good, not just for me, but for everyone. So let's first of all here show you on the web interface what would previously have caused a pre-charge hang. And a pre-charge hang could occur in the VCU in a number of ways, but the ultimate outcome is that the VCU would sit in pre-charge mode and would not come out of it at all. So you'd have to kill the 12-volt power and reboot the VCU to get it out of the hung pre-charge state. Now, you might say, well, okay, you know, not great, but how does that cause a problem? Because unless we're in run mode, we don't enable the inverter, and that's entirely correct. So, for example, if this happened with, say, a Nissan Leaf system, Mitsubishi Outlander system, it would just basically sit there. You wouldn't be able to drive the car because you press throttle, you're not in run mode, there's no torque demand, la-di-da-di-da. So you would never destroy the pre-charge system. But all it takes is the wrong, or indeed the right, alignment of circumstances, modules, etc. So in the E39, we have the Lexus GS450H. As we've just demonstrated here on the web interface, you can still see the value here. The Lexus Toyota inverters draw a little current when they're powered up, even when there's no torque demand. They're not going to turn a motor, take a little bit of HV current. And that, coupled with, let's say you had a charger or a DC-DC converter in there that was not being directly enabled from your VCU, then you could start drawing current. So several different circumstances would result in a destroyed pre-charge system. Not very good at all. So I'll demonstrate in a minute. Two little bits more to the story. I got to the circumstance here, and it was one of the first things that I fixed over the time I've been working on the code here. And I thought, oh, that's fine. And I had that fixed. And I was testing, making software changes, getting them out, then putting them through the test bench, putting them through the cars, just rinse and repeat for the last 2 weeks. And eventually I got another pre-charge hang. I thought, hang on, I can't have a pre-charge hang. I've fixed the pre-charge hangs. No, I hadn't. Because there was 2 mechanisms within the pre-charging system that would get you into a hang. The first was, if your pre-charge voltage had not reached the voltage at which the main contactors would engage, you would stay within pre-charge. But you say, hang on a minute, surely the pre-charge timeout would have stopped that. And indeed it would, as long as, and this was the real catch, as long as the DC voltage had not exceeded half of the UDC SW set point. So there was a little holdover piece of code in there, probably came from the early inverter days, that your pre-charge timeout would stop counting as soon as you came up to half of your set point voltage. So now that we have that fixed, not only can we not, touch wood, get into a pre-charge hang, but we can come out of pre-charge now at any point without having to power cycle and do all kinds of stupid things like that. So, a little bit of a story there. I'm sorry this video is going to be churning away. I know. The watch time, the watch time. Anyway, going to demonstrate here now for you. So if we have a look at our web interface here, you'll see that our DC voltage has dropped to 0 because I'm switched off. So an obvious thing to do is, let's say we have a complete failure in our high voltage system. Say for example we pulled the service disconnect and just forgot about it. So we would come into our VCU, put the ignition on, press the start. We're in pre-charge. And we've just timed out of pre-charge. And we just go to pre-charge fail. Now, we will stay in pre-charge fail and not allow anything else to happen, so any more pressing of keys or anything, until we switch off our ignition switch. And then we will return to off mode. And that's rather important, because one of the reasons that the pre-charging circuit failed in the E39 was because someone was a bit of a prat and messed with it. So there was all kinds of pressing of keys and throttles and the shifter and all kinds of that stuff. So the new mode control section in the VCU will not allow that to occur. It'll just sit there and ignore you. Now, let's say for example then that crazy birds. Let's say that our battery is a bit low, right? So let's set our power supply. Knock over everything, of course. Let's set our power supply to 12 volts. Nothing like a bit of professional filming, is there, folks? So our power supply is now at 12 volts. And you'll see that the VCU is alerting us now that UDC is below UDC SW. Now it would do that before, but as long as we were above half of it, the pre-charge timeout stops. But now, switch our key on, press start, we go into pre-charge, and aha, pre-charge fail. And again, we can press our start button, doesn't do anything. Until we turn our ignition back off, we do not come out of pre-charge fail. So, that was one mechanism. So that whole thing was one mechanism. And there was one more little tragic, feature in there. And it's funny how the human system works, and it's one of the reasons that it's one of the reasons that designing anything in isolation, be it a circuit board, a bit of code, anything, doesn't matter what it is a really bad idea, because there's a bias within us, and I'm definitely prone to that. And I hadn't realized this. So in previous versions of the code, I had based the principle of starting the VCU the very same way that you would start an internal combustion engine vehicle. So be it a traditional spring turn to start key switch, or be it the kind of newer ones where you push the start button. But there's even, of course, newer ones where you don't have to hold down the start button, and that's where we're getting to. So for me, I've always had a car that you got in, you know, you put it in neutral, you turn the key, or let the key off. And that's how I'd been starting up the cars here. I would get in, put it in neutral, turn and hold the key until the start sequence finished, release the key back after a few seconds and go driving. Would seem straightforward. And because I was doing that all the time, be it either in the cars or in the test bench, this particular problem didn't show itself until a third party got in the E39, checked it was in neutral, put the key in, and rather than rotating it and keeping it in the start position until the system pre-charged and started, just flicked it, which in an internal combustion engine vehicle would just give it a little kick of the starter. It would just go clunk. And what happened there is the VCU would see the start signal enter into pre-charge. As long as the measured DC voltage exceeded half of the UDCS W point, the pre-charge timeout stops. Now the VCU is looking for this ignition start signal to be on in order to complete the startup sequence, which in my mind made perfect sense, right? Because you don't want someone to accidentally get into the car and tip the key and have the car complete the startup sequence. Well, it turns out that if you did that and you just tipped the key, you would hang within pre-charge, which again, on most drivetrains is no problem until we get into either a Lexus Toyota version that draws a little current, or you have a charger or a DC-DC or some other load on the 12-volt system that is not looking for the VCU to send it a run signal. And guess what? You blow up the pre-charge system. So what happens now is, rather than the VCU needing to see the key held in that start position all the way through pre-charge and startup and contactor close, it will now interpret a flick of the key to be a request to start up, and as long as the various conditions are satisfied, that you don't have your foot on the accelerator, for example, it will run through pre-charge and start up without the need to hold the key in start. And that removes that secondary mechanism by which you could end up in a pre-charge hang that could ultimately result in destruction of the pre-charging circuit. So I'm hoping that makes some sense. What I'm going to do here now, just to wrap up this part, this video is going to be long. I'm going to show you a few things here. So for example, we're above half the set point voltage. If we go up to contact controls at 15 volts and we're at 12 volts. So what I can show you is, I don't know if the automatic is going to work so well on this here, but we'll try it. So for example here, I can flick the ignition on, initiate a start, but then I can switch off, by means of the ignition. So if I have accidentally flicked to the start position, I thought, oh crap, I can just turn the key back off and we'll come out of pre-charge and obviously out of run mode. The start of charging mechanism is also protected by this. So for example here, we have an external digital charging request. So I'm going to flick a switch on here. We'll see pre-charge, charge type AC. And you'll see now that we'll go to pre-charge fail. But we will not do anything else until the charge request goes away. And then we can go back to op mode off and have another attempt once we bring our DC voltage high enough or solve whatever problem there was. I'll just give you a view. There we go, to 18 volts now. So we can go into charge mode. There, no problem at all. We can come out of charge mode, and by switching our ignition on and just giving the key a tap, put the key on and give the key a tap, we go into run mode, and there we go. There's our GS300H motor turning. I can come down here. You should see some RPMs on there. There we go. So that's it for this section here with the test bench number 1. What I'm going to do now is I'm going to power down test bench number 1. We'll get you up and running on test bench number 2, which is our leaf PDM, our entire leaf stack, and we will show you that working. So stand by for more boredom. Alrighty, we are at this point. You'll see on the web interface we are connected up to our second test bench here, which has our Nissan Leaf stack, complete high voltage BMW pack. We're connected to the S box. So first things first, I will put us onto auto refresh mode here, so you'll be able to see hopefully what's happening. I'll scroll this up a bit here, just so you can see, be able to see op mode and a few other odds and ends there. So let's go ahead and start up. Put our ignition on, give her a shot at the key, and got our throttle pedal. Give her a little blip with the throttle. Now when I do, if I exceed like 1,000 RPM on the motor, the Volkswagen clock here is going to go pretty crazy because I'm not transmitting oil pressure to it. So here goes. There we go. Volkswagen going nuts. And of course this didn't bother to refresh or anything. But I think it is doing it now. Yeah, there's our RPM. So you should be able to see the motor spinning down there. See our temperatures, various other parameters there, nothing too crazy. You'll also see here reading the inverter voltage, and where also you'll see that there's some current consumption there because the DC-DC converter is functioning. So what I'm going to do next is, once the motor spins down, I'm going to switch off and I'm going to plug a granny cable into the charging socket here, and we'll get our PDM up just on a low power setting, just to show you the charging functional. So charging, there we go. Here are the clicks, and of course this won't refresh. Oh, of course it won't refresh because we're not connected anymore. Here we go. Come on, come on. Wow, professionalism at its very best. There we go, AC charging. There we go, charge mode. So see our voltages are coming up, and we have current, but we don't have power. And I know we could derive power, just multiply voltage by current. I might end up doing that, but I'd like to be able to get the messages from the S box. So that's charging. We can change the power settings on the charger and so forth quite readily. So let's plug that out. We should go back to off mode on there now if things are working right. Indeed they are, and we're back to off mode. So last thing then that I'm going to demo for you will be Chademo. Okay, so we are now set up to do a little Chademo demo. So I'm going to simulate plugging in, which will be the charger providing 12 volt size in one terminal or whatever it's called. So we'll do that. So we'll come over here and we'll see we are in charge mode. We haven't confirmed that we're in charge type yet here, because we pull up SavvyCAN, you'll see that we're sending out our CAN messages here for our Chademo side. And now if I just gonna play back some charger messages here, so 108, 109. If we now go in here, once the procedure goes through sufficiently, this will change to charge type DC-FC. There it goes. Now we can come down to our parameters here. We'll be able to see, for example, the available current and voltage on the charger. And now our current request is starting to ramp up here. So you can see that. And obviously, you know, we're just playing back what was a previous charging session. But that's Chademo functioning, and that's now, as I stated earlier, any combinations of these can be utilized in that way. So folks, I hope you've enjoyed that. It's definitely been a bit of a trip for me over the last 2 weeks through all this. As usual, I've learned quite a bit about C++ and so on, so that can't hurt. Okay, maybe it can. So, one last thing. With a bit of luck, crazy birds. By the way, got to show you the robins. Don't let me forget. They're not in nest number 1 up here. They've made nest number 2, and they're currently hatching. So, where was I? Oh yes, VCU. So with a bit of luck, next week I am going to be going EMC testing the Zombieverter VCU. I believe the standard we're going to work to is ECE R10. So obviously all of that results, good, bad or indifferent, will be published openly for you all to see. So see how badly my designs work out from an EMC point of view. So we're going to be doing the full radiated. I don't think there's any conducted done for that kind of thing on a car. That'll be only for chargers, I think. So we'll be doing radiated, and we'll be doing susceptance on that as well. And the automotive, I think standards for susceptance are quite high, so we could be microwaving a zombie. Anyway, that's about where things are at. This video will be way too long, I'm sure, anyway, so be sure not to watch it. But do check that video on the Volkswagen or V2.0 chargers that I will link in the description. As always, don't forget to give this one a thumbs down. Do not subscribe, and for Pete's sake, don't support me on Patreon or PayPal, because then you just get more of this kind of crazy stuff. And nobody wants this, especially not me. I'd rather be walking around in the fields, smelling the grass. Okay, we will see you next time. Hopefully I won't have got my brains fried by 200 volts per meter of RF. And we'll let you know how we get on there. And got a lot of car projects to catch up on as well. Ugh. Wow. How many car projects have I got to catch up on? I got to catch up on the Red Arrow. Panzer's kind of on hold for the minute until those Robins hatch out. And then we've got the Moskvo. Good news is I got this subframe nearly finished here. So then we got to get that in the car. We got to go drive shaft. Oh, yeah, I'm going to need a lot of VCUs. But that's good news for you folks, because the more cars I have, the more VCUs I have. The more VCUs I have, the more testing we get to do, and the more modules we get to add in. So right. Until next time. Happy susceptance testing.